All right, good afternoon, everyone. Thank you all for joining us here today. I know it's definitely not easy during these very difficult times. I'm Lucy Chen, and I'm the marketing director here at Zemarc. Today, we have a very special training by our world-class engineering team on the basics of hydraulic power units. So before we get started, I'm going to give you a quick background on Zemarc. We're very lucky to have two members of our engineering team here today, Chris Matuzik and Elizabeth Meyer. We also have some quick giveaways as promised, so make sure to stay tuned at the end so then we can do the raffle and call your name. So Zemarc was established in 1976. We have over 40 years of successful experience in the industry. Zemarc is a fluid power distributor providing industry-leading fluid power solutions like power units, cylinders, pumps, motors, valves, accumulators. We even have filters and fluid connectors and many, many more. We have 4 different locations across California, which is Los Angeles, Oxnard, which is in the Ventura area, Fresno, and Hayward. We also have representation out in Arizona to support anyone that has needs there. Los Angeles and Oxnard are our 2 Parker stores, and we do have a hydraulic service center in Los Angeles and Fresno. Our test bench can support up to 100 horsepower. So Zemarc is an authorized distributor for Parker Hannifin, Enerpac, Lincoln SKF, Delta, MTS, and other fluid power brands that you may recognize. We offer full service design, build, repairs on a wide variety of power units, cylinders, pumps and motors, and other fluid power solutions. We can support also these, we also support these systems with available inventory at our local locations and our Parker stores. So we could do your quick hose assemblies at any one of our 4 locations. So if you take a look here, just a reminder, if you didn't already know, Zemarc is a full line distributor of Parker Hannifin. We can help you with your full application instead of just a portion of it. And our engineering team is excellent at supporting interoperability in your system. So today we're focusing on hydraulic power units, known as HPUs. Our Zemarc engineering team who is presenting in this training is also very well known for their ability to assist with these HPUs. So they can definitely assist you with standard options as well as design and specify something that's custom to your needs. So let's get started.
Hey, I'm Elizabeth Meyer, one of the sales engineers at Zemarc, and I'll be walking you through how to set up a power unit. So a hydraulic power unit, also known as an HPU, is one of the most essential parts of a hydraulic system. HPUs provide the power for every hydraulic system, and each HPU has a pump, a reservoir, a motor or engine to drive the pump, and an assortment of accessories. These elements provide and control the flow for your hydraulic power unit and your system. We've done hydraulic power units for a variety of industries. Pretty much anything that uses hydraulics uses a hydraulic power unit. Some common industries we work in are like ground support, testing applications for aerospace, general manufacturing, construction, maritime uses, transportations, and more. So let's go through the key considerations for specifying your hydraulic power unit. The hydraulic power units are built based on the requirements of your application. These requirements are all based on the actuation used: motors, cylinders, rotary actuators, etc. How these actuators work in the system will determine the pressure and the flow rate required for your system and how the system will be cycled. Pumps are one of the main elements in any hydraulic power unit, and they provide the flow for the system. Pumps are sized based off of displacement, which is the amount of fluid moved by a pump in one revolution. Flow from a pump is determined by the speed and displacement of the pump. Flow from your pump is pretty easy to calculate. It's just based off your displacement and speed. You divide them by a conversion factor to determine your flow rate in gallons per minute or liters per minute. There are two main types of pumps used in hydraulic power units. They're fixed displacement and variable displacement pumps. Fixed displacement pumps have a constant displacement. The only way to increase the flow in a fixed displacement pump is to increase its speed. Variable displacement pumps have an adjustable displacement, which means their flow can be changed independently from their speed. Prime movers are used to power the pump and provide their speed. The most common prime movers are electric motors and gasoline and diesel engines. Engines are a bit more involved to size in, so contact a Zemarc engineer for engine-specific questions. As for electric motors, they're selected based off of their power, speed, and voltage. Power is determined by the flow and pressure of your system. 1800 RPM is industry standard for high-speed, but high-speed motors are available. For systems where you need variable speed, variable frequency drives, known as VFDs, can be used. You'll need to know the electric power source available for your motor. For DC motors, you'll need to know the voltage. As for AC motors, you'll also need to know the phase and frequency you will be using. To calculate power, you need to have a few different variables. The power required by a pump determines the minimum power rating of its motor. The pump's required power can be determined by the equation in this slide. As the pump's output flow and/or the power increases, so does its power draw. Note that the efficiency of the pump means that the pump draws more mechanical power than the fluid power it outputs. The efficiency of a pump can be found in its catalog. These catalogs often have power curves that will show a more exact power rating. And one of the other main elements of a hydraulic system is the reservoir. Reservoirs house the hydraulic fluid for a system. When first choosing a reservoir, you should estimate the volume of it, which is about 3 to 4 times the flow rate. The bigger the reservoir, the more heat and air can be dissipated from the system, but the more space used. The reservoir size can be decreased by adding in a cooler to improve heat loss. The reservoir size will need to be increased when adding large volume adders, like cylinders and accumulators. There are 3 main types of reservoirs we use. There's vertical reservoirs, where the pump is submerged in the reservoir. These are compact and provide increased cooling and can help prevent cavitation. Horizontal reservoirs have a simple design which allows for specialized mounting, such as overhead mounting. And finally, L-shaped reservoirs allow for greater heat dissipation and can provide mounting space for the rest of your system. The pump, prime mover, and reservoir are the 3 fundamental components of an HPU. A few additional components are also required for a safe and reliable system. A relief valve discharges excess flow to limit the system's maximum operating pressure, while a check valve at the pump outlet prevents back pressure on the pump, which could damage the pump and motor. A ball valve at the pump inlet allows for easy maintenance. This is recommended for horizontal and L-shaped reservoirs. Finally, return filters remove contaminants from the working fluid before it returns to the reservoir. This protects your components from damage and excess wear. There are many common accessories that aren't needed for every system, but are recommended to protect your hydraulic power unit. These are filters, heat exchangers, accumulators, instrumentation, and manifolds. Additional filtration may be needed depending on the environment and application to increase the life of a system. Sensitive equipment, such as proportional valves, often require a higher level of filtration and require an extra filter being placed in your system. Heat exchangers can be installed in systems if there's concerns about your fluid temperature. Coolers are often used when a hydraulic power unit is in any situation where large amounts of heat will be generated, such as long periods of cycling. A good rule of thumb is to size coolers so that the heat removed is about 1/3 of the power input to the system. Heaters are less commonly used and are placed in hydraulic power units located in cold environments. You can find more information at zemarc.com/thermal. Instrumentation sensors give feedback on the hydraulic power unit for safety and maintenance and allows for troubleshooting the system. While not required, they can often help lengthen the system's lifespan. Gauges are useful as they can give feedback in live time for operators. Switches can be used for simple mechanical controls, and transducers give digital feedback that can allow for more advanced computer control. The most common measurements for a hydraulic pressure unit are for pressure, temperature, and reservoir oil level. Accumulators can be added into systems for many reasons, such as a backup system in case of a power loss, systems that require a low pressure for long periods with brief periods of high pressure, and to absorb shock loads. Manifolds are very beneficial to applications with more than one actuator or multiple accessories. They allow for better flow rates to each actuator and more compact and organized system setups. The team at Zemarc Engineering is available to help you with custom manifolds. Just to summarize, when you are designing your power unit, you want to make sure you've taken into consideration all factors that you need to size your pump, motor, and reservoir. You want to also make sure you've thoroughly thought out what accessories you'll need. That way, when you approach a Zemarc engineer, you will have a better idea of what you need in order to discuss the best way to create the most efficient and cost-effective solution for your project. Now I'm going to be passing the presentation over to Chris.
All right, I believe I am unmuted. Hello, everyone. My name is Chris. I am also part of the engineering team at Zemarc here in Los Angeles. And Elizabeth told you a little bit about all the individual components in an HPU, and I will talk a little bit about the options that you guys as customers have in selecting an HPU. So we've explained the process through which we build a custom HPU to our customer specifications and requirements. We can arrange these components to form different types of circuits that perform specialty functions or improve the efficiency of the system or anything else, really. But for low flow conventional applications, Parker also sells off the shelf units. These are their D, H, and V packs, as well as their oil dye compact units. Now, their power units are not actually quite off the shelf, but rather they were built to order based on a small list of standard primary components and optional accessories. So when our customers do not have a specialized application or specific uncommon requirements, Parker's HPUs are packaged neatly. They require a lot less time to design and assemble, and depending on the specific case, they can be more cost effective as well. And what's also really nice is that Parker's online configurator allows customers to easily specify their own power unit. So let's actually run through the process of building a D-pack as an example. So first off, we'll start with the three basics. These are the pump, the motor, and the reservoir are the three basic components in any HPU. And in order to choose these, we need to know our required flow rate and our required pressure rating, from which we can determine our motor rating and reservoir size. So let's make up an example and say we require a flow output of 1.5 GPM at 1500 PSI. We would then reference page 30 of the online catalog to determine which pump and motor are sufficient to this application. We can see, according to this chart, that we will need the 1.8 GPM pump to meet our minimum flow requirement of 1.5. And if we follow the road to the right, just right there, the 2 horsepower motor provides enough power to accommodate 1700 PSI, which meets our minimum pressure requirement of 1500 PSI. So there we have our pump, we have our motor. I'll talk a little bit about the reservoir in a little bit. So now I'm going to take us out of the presentation real quick and show you guys the configurator on Parker's website. You can also find this at zemarc.com/HPU, I believe. You can reference that back on these slides when we release this video. But here's their configurator. So let's go and just walk through the steps of selecting all the options and accessories in putting together this example HPU. So first off, the reservoir. D5 only has a 5-gallon reservoir, so that actually skips that step for us. Most of their other HPUs do have several size reservoirs you can choose from. So as we go down through here, let's select just a regular pressure control. And it looks like it's running a little slow for me. Yeah, occasionally the website can act a little bit like this. In this case, there are many different options for pressure relief. There can be bypass valves for the motors. There can be... Actually, hold on. What is going on here? Give me just a second. Let me exit out and try to get back in here. There we go. Everything's working now. So we've got our pressure control. Now let's choose our 1.8 GPM pump that we mentioned before and our 2 horsepower motor right here. Now, some customers may want to provide their own motor. That's not very common, but if they do, you can also order an HPU without a motor by selecting this checkbox here. But we're not going to do that for this example. Manifold, we'll just choose a standard manifold, and I'm going to take a quick pause here. And as you can see up at the top, the configurator is spitting out this code as we're updating these options and accessories. Each of these letters and digits correspond to each of the choices that you make. So as we move on here, we'll put in some accessories. Now that adds a P to the code, and just walk through this whole thing. Sure, why not? A heat exchanger is always a good idea. And we'll just select all these accessories. Return filter, we should always have a return filter. Float and temp switch. And now at the end, we will have a complete part number up here at the top with which you can order your fully assembled Parker power unit. So let me just go right back to the presentation now that we've got that section done. And there we go. So just a reminder, Zemarc Engineering is here to support all of your needs, whether it be standard power units like the ones I've just showed you, custom power units, or other fluid power solutions like custom manifolds, fatigue test stands, or really anything else hydraulics. To get started, it's very simple. Just know what you want and then contact us. Someone from Zemarc Engineering, like Elizabeth or myself, will review possible options for your application and get back to you with pertinent options and questions to move your project forward. Then we'll design a solution with optimal efficiency that can be delivered in the time frame that you need. We take care of that heavy lifting while you can go about other things in your day. So that's really all I have to say. There are the Parker units and there's custom units. And if you don't want to configure your own unit through the configurator, then just call us up and we can help you out with that, or we can design a fully custom unit for you. So with that said, I will pass it back to Lucy.
Great, thanks so much, Chris. Well, thank you, Chris and Elizabeth. You guys did an amazing job with the training. So now we're going to take some questions. So go ahead and enter any questions that you may have about specifying hydraulic power units, or just where the configurators are, etc. I'll go over some of that detail a little further as well. So while you do that, I'm going to do the raffle and provide some additional information. So here are some different ways you can reach us to get started with your project today. You can email sales@zemarc.com with your requirements or completed model code per that configurator. Or you can also fill out a form that's on zemarc.com/HPU. It also gives you the option to include the model code or just list the requirements of like flow, pressure, etc. With some side notes. You can also download the Parker Standard Power Units catalog on zemarc.com/HPU. We made it extremely easy for you. And then also the configurators for the D-Pack the HPAC and the VPAC are also listed on that same web page, zemarc.com/HPU. We just listed everything there for you just to make it easy. Also, we are also available on chat, and you can also call our main switchboard, which is 323-721-5598. You can ask for engineering or someone in sales to help you with your needs, and we'll be gladly to assist you. So with that said, please continue to enter any of your questions. I'm going to do a quick raffle. We have 2 items here today. So I'm going to put all our lovely attendees here in my random generator. So the first up, I have a goodie bag that has a very cool Zemarc measuring tape in there. It has a leveler attached as well. That's really, really cool. And a Zemarc 8.5 by 11 inch engineering graph pad, along with a set of chrome blue and silver Zemarc pens. So with a drum roll, the winner is Gloria. So Gloria, I will reach out to you. I think there's only one Gloria in this training today. So Gloria, congratulations. I will reach out to you about how to redeem your prize. So next we have a powerful idea, start here, Zemarc t-shirt. It's actually wicking for air. It's good for wicking air, so it's our sweat and air. So it's actually a nice material, not just your standard cotton t-shirt. But we'll also throw in a goodie bag with that too. So the final winner of this training today, drum roll here, is David Morton. So David, I will contact you about your prize, and we'll go from there. So congratulations to our winner. I'll reach out to you, so make sure you pay attention to your email to get back to me with your details. So let's take some questions. So look right here. First question is from Carlos. So Carlos is asking, do you provide any troubleshooting guides? Elizabeth, are you familiar with what troubleshooting guides are available on?
Well, if you're talking about troubleshooting for power units, it varies. If you're working with something standard like an HPAC or a DPAC, there's the installation manuals that can provide troubleshooting help. But if you're going to be working on a more custom power unit, since those are really very custom and each power unit can be really different from one another, there's not as many troubleshooting guides online. If you're having specific problems, you can contact me or any other Zemarc engineer and we can try to help you out. If you're looking for guides, I guess you can contact me and I can see what else I can find for you. I haven't seen any that are particularly helpful, but that's just because a lot of power units are very custom. I hope that helps out a little bit.
And to add on to that, by custom, we mean that the power units that we design are usually from the ground up. We select each individual component and then put it together, so there is no literature except for each individual component. But like Elizabeth said, we provide an installation and operating manual with every project that we sell.
Thanks so much. So I'm going to take a few more questions here. So we have a question that says, what are some good examples of using a heat exchanger?
All right, so a heat exchanger, I personally like to put a heat exchanger in almost every power unit I'm using just because there's many ways you can generate heat. And there you can get a lot of damage from heat just from going through a relief valve. So in general, it's good to put one on, but if you are looking for specific applications, I've had to put some more specialized heat exchangers in systems where we're working out in the desert, where you're getting a lot more heat input from your environment, or with systems where, like I said, you're going to have a lot of flow going from relief.
Okay. All right, let me see. There's our There's a couple more questions here. It says, what do you recommend that will help keep out airborne contamination?
Well, there's a few different solutions we have. Every hydraulic system that we have a reservoir that has a filler breather. So this allows air to get into your system. And there is a little catch on the top so it prevents any larger debris from going in. But if you're dealing with a very dusty environment, you might want to have a small filter inside of that filler breather. Or if you're in a very moist environment, you can put a desiccant on top of it. Or for really moist environments, we have a actual specific option called a hydraulic reservoir isolator. And these allow your reservoir to breathe. So as pressures change, your air goes into a bladder bag that's sealed off from the rest of the environment. So you don't get any contaminants that were in the environment. The only air contaminants are what was in your system originally. So it's really convenient if you have something that might be a really moist, maritime environment where you can get a lot of water in your system.
Great, thanks, Elizabeth. So I have one more question here. So last chance if you guys want to enter any more questions while we go through this last one that I have right here. Just go ahead and enter onto the question box on the left-hand side. So the last question I have here is, what should I do if I need to place a power unit in an environment with high humidity?
Oh, well, it's very similar to the one I was just answered. That's where I was talking about the hydraulic reservoir isolator. That's what I personally recommend just from my experience is using the Parker CleanVent. It's a newer product they have, but it's very helpful. Like I said, since you have that bladder bag where you have your air inside of it, it doesn't allow any water or moisture from the environment from getting in there. So if you install this ahead of time in a environment such as a shop that's farther away from humidity, that just keeps all the air that was in there originally and can prevent any of that water getting into your reservoir, because water getting into your pump can really damage it and it can corrode other components and lead to some pretty nasty wear.
Great. Thanks so much, Elizabeth. So I don't have any more questions. I want to thank everyone for participating today and attending here. I know it's a very difficult time, so I do wish everyone to have a very safe day as well as a pleasant day. And if you need any assistance, have further questions as you think of it, feel free to reach out to us here at Zemarc by calling us. We're all very friendly, as you can see, so give us a call. You can also email us, and we're rather quick at responding as well, so do that. And we also have chat resources if needed. Our website does have those resources linking back to the configurators and the catalogs, and also a white paper that goes over exactly what we went over today on specifying hydraulic power units. And that white paper can be found at zemarc.com/HPU, or the direct PDF is zemarc.com/HPU white paper. So with that, I would like to thank everyone again, and I hope you enjoy your day.